Okay, looking at the first example, so we've got 5 sculptures, 3 modern art, 2 charcoal sketches. So we want to make a display, and we're just going to choose 3 of them. What is the probability that you pick 3 and you contain at least 1 piece of modern art? This at least is a really important word here. So we first start off just with N of S. How many ways to pick any art? We can group them together. If I ask you what question this is like, you would say it's possibly like the cards question. This is just a deck of cards, except instead of 52 cards, we only have 10, and instead of 4 suits, we have 3. And so if we want to choose 3 of them, we just do your 10 choose 3. For N of A, we're going to look at 2 ways to do it. Solution 1, we would look at 1 piece of modern art and 2 others. The reason why we say 2 others, this is really important. We're going to group all of the others. So these 5 sculptures, 2 charcoal sketches, they're all the other cards in the deck. We don't really want to break them up because it'll just lead to some complication that we don't need to get into. So 1 piece of modern art, we have 3 choose 1 times 7 choose 2. The temptation here is for people to say 3 choose 1 times 9 choose 2 and then say I'm done. The problem with cases is you really have to be very specific with probability. The problem with saying 3 choose 1 times 9 choose 2 is you'd actually be double counting. Like you can imagine that 1, so there is a possibility that you have 3 charcoal sketches. Sorry, 3 modern art. 3 choose 1, you pick 1, and then the other 2 you choose in this section. But that case could come up if you did 3 choose 1 and you chose a different one first, and then you chose 2 in the next section. So what you do is you end up double counting. So you count too much, and you'll end up getting way more than 120 as your possibilities. So case 2, so that's 63. Case 2 is 2 modern art, 1 other. So 3 choose 2 times 7 choose 1. And then case 3 is 3 choose 3 times 7 choose 0. And notice like we've got that other, even though 7 choose 0 is just 1, and even 3 choose 3 is just 1, we're just for completion, we're showing all the different cases, all the steps. So this is just 1 times 1, it's 1. Add those up, we get 85. So probability, we could just do 85 divided by 120. Other solution is to do the indirect method. With at least 1, the opposite of at least 1 is none. And so we've just done 1, 2, 3. You could certainly do none. And so the ways to pick no modern art would be 3 choose 0 times 7 choose 3. And 7 choose 3 is like 3 choose 0 is just 1. So 1 times 7 choose 3 is 35. Take that away from 120 and you get 85, and that's the same answer. And so your probability is 71%. So at least 1 piece of modern art. Second example, we've got school in different grades. We're going to say a group of 40 students that we'll say represent the school. So 20% of them, 25% of them are grade 10, 11, 25% of them are grade 11. Apply for 20 positions. So the question is like, how many ways can you make up the council? And so this is a deck of cards as well. Again, it's just not the same in each suit, but it is a deck of cards. What might be helpful is to find out how many of each grade you have. But in the first question, which would just be like N of S, we just choosing like it's like your 40 or 52 choose 5. It's 40 choose 20, and that's a lot of different ways. 137 billion. Probability a random group has the same percentages as a school. That's where you have to kind of break them up. And so say, like we want to make sure that in the 20% of the 20, and 25% of the 20, and 25% of the 20, and 30% of the 20 are those different grades. So we know that 8 grade 9s choose 4 of them. 4 to 20 is 20%. 10 grade 10s choose 5 of them. And, so that's the multiply, we're doing and. 10 choose 5, and 12 grade 12s are choosing 6 of them. Multiply all those numbers together and you get 4 billion ways. And if we divide those, we get about 3%. So not a very high likelihood that we're going to get the same makeup. Which kind of makes sense. Like it's easy just to have one too many And actually 97% of the time you're going to have one too many. It's very similar to a deck of cards. Example 3, determine the total number of ways that we can select an outfit. So the question's not really here, but like you've got like the outfits that you're selecting from. If you ask the question like, what's this like? Is this more like a deck of cards or more like a password? You realize that it's kind of more like a password. This is a tree diagram question. So we go to 4 slots. Number of ways to do a shirt is 4, pants is 3, ties is 4, and shoes is 2. This isn't a permutation. This is like the slot method. So we don't officially call it like 4 times 3 times 2. Probability mix a plaid shirt with striped tie. N of A is got to be in 4 cases or 4 slots as well. We need a plaid shirt, so there's one way to do that. We need a striped tie, which is one way to do that. 3 ways to do the pants, doesn't matter, and 2 ways to do the shirt, shoes, so 6 ways. So the probability is 6 out of 96. Probability you wear black in only one item in your outfit. There's where you got multiple cases. So you realize how many cases you have. Case 1 is a black shirt. So you got four like slots. There's 1 black shirt, and then 2, 4, and 1 not black pant, tie, and shoes. Case 2 is black pants. So we've got 4 slots. 1 way to do the black pants. 3, 4, and 1 ways to do not black everything else. And then black shoes. 1 way to do the black shoes. 3 ways to do not black shirt. 2, and then 4, which is 24. If we add those up, because we can't get a black tie, we get 44 out of 96, and so it's 46%. Okay. Last example for this video, you have 100 songs from 10 artists. For the sake of the examples, 10 songs from each artist. So I know like phones nowadays like just have like unlimited songs, but if this was your cell phone, then this would apply to you. You always listen to music by allowing the phone to play at random, so shuffle. How many ways could you listen to the first 3 songs? So I probably have to be more clear that the order doesn't matter in which that you listen to songs. If you listen to 3 songs, like it's just like if you listen to song 1, song 2, song 3, that would be the same thing as if song 3, 2, 1 came up in that order. So this is actually it's kind of a little bit simpler to do as a combination. So there's 100 choose 3 ways to listen to songs, 161,000. Probability that the first 3 songs you listen to are from the same artist. So then we can say, well, let's just do it for an artist first. So say any artist, and we say out of their songs, like there are 10 songs, we're going to choose 3 songs. But then there would be 10 cases. So there'd be 10 of the exact same case. So you could say 10 choose 3 for each artist, and just add them up. And that's 1,200. And then how many times do you expect to hear? So it's based on the probability. So just like that's a little bit understanding the probability, but 135 days, if we listened once a day, if we multiply 0.74% by 135, we actually get 100% chance, and so that would give us a 1 or 100%, and so it would take we'd expect 135 days for you to hit like all the different possibilities, and so possibly hitting 1 artist in the first 3 songs. And then if you listen 10 songs, was probably they're all from different artists, your N of S changes there. It's like 100 choose 10 now. All from different artists is like 10 choose 1 times 10 choose 1 times 10 choose 1 10 times. And so that's 10 to the 10 out of 100 choose 10. And so you've got this probability of 0.058%. Very unlikely that you're going to hit all the different artists.